Hello, and this is my Module 3 video about sensitivity and specificity and how it relates to the FST test. In general terms, sensitivity and specificity. Sensitivity is when the test is positive and in reality you actually are positive. For example, if you have cancer and they test you for cancer, the test will come out positive and you actually have cancer. Specificity is when the test comes out negative and in reality the result you are actually negative. So in a cancer test, it would say that you're negative for cancer and you really don't have it. In terms of an FST test, sensitivity is when the FST test says that you are drunk and you're actually drunk, and specificity is when it says that you are sober and you're actually sober. FPR is when the test says that you are drunk and in reality you are sober. FPR means false positive rate. FNR is false negative rate, and that means that the test says that you are sober and you are actually drunk. What are the consequences of a high FNR and FPR in this scenario? If you have the consequences of an FPR is that you're wasting the time and money pulling people over and testing them when they really are sober. And the consequences of a high false negative rate, which is when you are pulling drunk people over and saying that they're sober, is that the drunk person could hurt someone or themselves, will get in an accident, and other things like that. How I would change the cutoff point of a FST and how it will affect sensitivity and specificity. For example, if I increase the FST rule, then sensitivity would decrease because the allowed BAC will be higher, and vice versa. Using the data set in the back of the book, explain how a student would calculate the FPR and sensitivity for rule of 6. Okay, so this is our chart that we have in the back of our book, and here are the FST rules. It starts off with 1, 2, 3, and it increases, and the total FST is people that were tested sober for the field sobriety test. For the rule of 6, here's our 6s right here, you're going to count all of the people 1 through 5. So for this, it was a total of 51 people that tested sober. And I have my handy dandy chart. Okay, this is the chart that I filled out for an FST rule of 6. You can see the total people that tested sober were 51. And then out of that total people, you have to go back through and look at the actual BACs. And this is when the false positive rate and false negative rate comes into play. For example, the actual person's BAC for this is 0.02, and he tested sober, and he actually is sober because it is less than 0.04. And this person right here tested 0.048, and it said he was sober. Well, this is a false negative rate. This person is actually drunk, so he should have been positive. So, all in all, there were 30 people that tested sober and were actually drunk, 21 that were tested sober and actually sober. That's your specificity. And I got that by subtracting 30 from 51. It gets me 21. Drunk people that tested sober was 8. The sensitivity was 237. And these are my totals that were given to me. In totals, there are 29 sober people, 267 drunk people. And all I did to get the 8 was I subtracted the 21 from 29, 30 from 267, and then this added up to here for the 296 all in all total. All right. And then I also made a table to show my sensitivity and false positive rates. And here this is. And I got this by dividing for false positive rate. I would divide, for example, 8 divided by 29, because this person tested positive for being drunk, and it was actually negative. He was sober. So 8 divided by 29, And then my sensitivity rate, you test drunk, and in reality you are drunk, is 237. So 237 divided by 267. And then I did that for each of the FSTs, 1 through 10. And there are my numbers. And as you can see in the graph, the FPR continually decreases because as the BAC increases, there are going to be more drunk people, and you're going to have less of a false positive rate. And sensitivity will stay high because they're doing what they should and they're catching all the drunk people. So, and then, and then the best rule would be 7 and 8. 8 because FPR is low and